Welcome to Brain Vision.
So now we'll work on problem 47 from chapter 5. In this problem, we're asked to write Lewis structures for 4 ions, including resonance structure and formal charge. Also, we're told we may need to expand the octet to minimize formal charge. So we can start with part A, where we're given the phosphate ion, PO4 3-. So here we have 32 electrons, 24 from oxygen, 5 from phosphorus, and then 3 from the negative charge. So we have 32. And then we can start drawing our structures. So we're going to have phosphorus as the center atom. We're going to bind it to 4 oxygens, which will consume 8 electrons. So then we go ahead and assign the lone pairs around the oxygen atoms. We have 24 electrons to assign, so we can assign 6 electrons to each oxygen. And so what we see here is that we have each atom with an octet, so it's satisfied in that regard. However, the formal charge on each of these oxygens would be -1, and the formal charge on phosphorus would be +1. So we can minimize this formal charge a little bit if we have one oxygen share one of their electrons, 2 of their electrons with the phosphorus. So this is what they mean in the problem when they say expand the octet as necessary. So we're now giving phosphorus 10 electrons. But if we assign formal charge here, we're going to see that on this oxygen on the left, we have 0. On the phosphorus, we have 0. And on the oxygen on the left, we have -1, and on the top and on the bottom. So our formal charges add up to -3, which is the correct charge that we're looking for. And we've done that by reducing these 2 formal charges to 0, where before, without sharing the electrons in the double bond, we had -1 and +1 there. So that's the rationale behind reducing the formal charge. So this this double bond here doesn't have to form with the oxygen on the left. It could form with the oxygen on the bottom. Or any of them, as we will now draw. And then the final resonance structure will be the oxygen on the top sharing the electrons. So if we assign formal charges for each of these situations, the charges will be the same. They're just going to rotate, the 0 on the oxygen will rotate around. So here we're going to have 0 on the bottom and in the middle, and then we have -1 left, top, and right. Here we have 0 on the right and in the middle, and then we have -1 top, left, and bottom. Here we have 0 on the top and in the middle, -1 on the right and left, and the bottom. So that's for phosphorus in part A. In part B, the ion which we're given is cyanide, Cn-. So here we have 5 electrons from nitrogen, 4 from carbon, and 1 from the negative charge. So we have 10 electrons total. So we have just two atoms, so we bind them together. That takes up 2 electrons. So we have 8 electrons left to assign. And so we see that we can't create an octet here on both atoms. So we're going to need to share some electrons. So we can add a double bond here, and that leaves us 6 electrons to assign. However, if we put 4 here, we'd only have 2 left for here, which would not satisfy the octet for carbon. So we're going to need to add one more bond. So we've now assigned 6 electrons, and we have 4 left to assign. So we add one lone pair to each atom, and we have 8 electrons around each atom. The formal charge on carbon is -1 because we have 4 minus 5, and for nitrogen it's 5 minus 5, so it's 0. So the formal charge adds up to the charge of the ion. In part C, we're given sulfite, SO3 2-, 6 electrons from sulfur, 18 from oxygen, 2 from the negative charge gives us 26 electrons in total. Now, we draw our sulfur centrally. We bind it with a single bond to the 3 oxygen atoms. So here we have used up 6 electrons. We have 20 left to assign. So we can put 18 around the oxygen atoms. And then the 19 and 20th we put as a lone pair for the sulfur atom. So again, the octet is satisfied for each element here. But if we calculate formal charge for this structure as shown, we would have a -1 for the oxygens and +1 for the sulfur. Since that is similar to part A where we had phosphate, we want to minimize this charge. So we're going to take 2 electrons from one of the oxygen and bind it to the sulfur. Now that gives us formal charges of 0 for the doubly bound oxygen, 0 for sulfur because it's 6 minus parentheses 4 plus 2, -1 on the oxygen and -1 on the other oxygen. So that gives us a total charge of -2, which is correct. And we did take the extra step of sharing the one of the oxygen atoms, electrons, with sulfur in the form of a double bond. So we've minimized the formal charge. But again, we're going to have a resonance structure because it doesn't have to be the oxygen on the left that's sharing the electrons. So we move the double bond to the top oxygen and assign the rest of the electrons, and then we can move it to the right, and the left and this top oxygen are singly bound. So again, we can assign formal charges: 0 for the doubly bound oxygen, 0 for sulfur, -1 for the singly bound oxygens. Same thing here. So that's the resonance structures for part C. In part D, we're given ClO2-. We have 7 electrons from chlorine, 12 from oxygen, and 1 electron from the charge to give us a total of 20 electrons. We draw our chlorine centrally, singly bind it to 2 oxygens. So now we see that we've used up 4 electrons. So we can assign 12 to the oxygen atoms, which leaves us with 4 electrons left. So we can assign them to the central atom. So we see here, once again, that everything has an octet. However, if we were to do formal charges, we would have -1 on the singly bound oxygens. And here we would have 7 minus 4 plus 2, +1. So again, we can minimize this charge by sharing the electrons from one of the oxygens with the chlorine. So we take first from the electron atom on the left. Now we look at the formal charge, it's 0. Instead of 7 minus 4 plus 2, we have 7 minus 4 plus 3 for chlorine. So we have 0 here as well, and then we have -1. So because it doesn't have to be the oxygen on the left that's sharing the atoms, sharing the electrons, we can switch where we have the double bond on the right side. And we just simply change the formal charges. So you have -1 on the right now, and this is the correct structure.